Okay, so this video is looking at anti-differentiation, and this pains me because actually anti-differentiation is called integration, but for some reason in the new standards we're not allowed to talk about integration, so I still am, because you need to know that this is what the opposite of differentiation is, and it's really useful when you get into calculus next year that you get the idea that integration is the opposite of integration is the opposite of differentiation, and it's really useful. Of course, we're going to use it in a very particular way for this standard. So first off, we need to decide a method, and the method's this. If it's got to undo the differentiation, then you've got to add 1 to the power, you've got to divide by the new power, and then a crucial part that we haven't discussed before, but every time we differentiated, the number at the end of the equation, the y-intercept or whatever it would happen to be, if you want to think it that way, got cut off. It just got lost. So we need to add a constant. And we call it the constant of integration because it's the constant we add while we integrate. But that's a key point. So I've been told dy by dx was 4x plus 3. So that was my gradient function, that's my differential. But I want to work out what y equals, so y equals the integral, that's what that symbol means, 4x plus 3 with respect to x, so that's what the dx is for. So the dx before told me I differentiated with respect to x, this tells me I'm integrating with respect to x. It's important we know what we're integrating with regards to because it changes what we do to it. So I'm going to add 1 to the power, so 4x has got 4x to the power of 1, so I'm going to add 1 to the power, so that gets 4x squared, and then I divide by the new power, so that's over 2. Plus, now 3 is x, 3x to the power 0, so now that's going to become 3x to the power 1 over 1, and I'm going to add my constants in integration. Sweet, I'm there. I've integrated, so y equals that. Now, of course, I can neaten that up because 4 divided by 2 is 2. 3 divided by 1 is 3. So I get y equals 2x squared plus 3x plus my constant. But I've been told this point. I've been told it goes through 1, 4. So I'm going to substitute that in. And I'm going to get 4 equals 2 lots of 1 squared plus 3 lots of 1 plus my constant. So that's 2 plus 3 plus my constant equals 4. So my constant equals minus 1. So I can now say with definitive confidence, oops, I wrote down the number 3 when I really didn't need to. It's 2x squared plus 3x minus 1. I have anti-differentiated, and there you go.